Here are 3 extra examples if you need a little additional help with either simplifying radicals or the complex numbers. So if you try to take the square root of a number and you come out with a decimal, then we need to simplify the radical. So we're going to begin with using the part that's inside the radical, and we're going to write it out as the prime factorization. And to find that, we're going to use the birthday cake. So start with 108, and you're going to make it look like a division problem, and you're going to divide by the smallest number other than 1. So the smallest number that 108 is divisible by other than 1 is 2. So this just looks like a division problem that you would have done when you were a kid. 108 divided by 2 is 54. So that goes on top. Now we're going to stack another one. We're going to do another division problem on top of it. We're going to stack them. So 54, the smallest number that 54 is divisible by other than 1 is 2. And 54 divided by 2 is 27. And we're going to continue on. 27 is not divisible by 2. The smallest number that we can divide 27 by is 3. 27 divided by 3 is 9. 9 is divisible by 3, and we get 3. And the smallest number other than 1 that 3 is divisible by is 3. 3 divided by 3 is 1. There's our 1 on top. Kind of looks like the birthday candle. That's how we know that we are done with them. And this right here is the prime factorization. So 108 is 2 times 2 times 3 times 3 times 3. So then we look up at our radical and we look at the index. If there's not a number in the index, remember that means that it is a 2. So that's what tells us the size of the groups that we need in order for it to come out of the radical. We need 2 of any number in order for it to come out in front. So there's a pair of 2 2s, which means that I can bring a 2 out in front. There's a pair of 2 3s. So that number that I have a pair of, I can bring that out front. So I can bring a single 3 out in the front. And then the number that's left over, or any numbers left over, it could be more than 1. So that 3, that has to stay inside the radical. It remains inside because it didn't have a pair. So that 3 stays inside the radical. And then we simplify if we had, so here we have 2 times 3 on the outside, that is 6. On the inside, all we have is 3. If we had something else left over, like a 5 or another 2 or something, then we would multiply those together. Also, this one just has a 3. So the simplified version of the square root of 108 is 6 radical 3. If we move to our second problem, this one has a square or a negative inside the radical. So remember that we've never been able to do anything with that before. We've always just said that that's no solution, it doesn't work. But now, anytime we have a negative inside a radical, we use an I for that. So for the negative, we make that an I. So it becomes I times the square root of 32. And then we do the exact same thing that we did in the problem above. Now we're going to simplify square root of 32, starting with the birthday cake to write the prime factorization. So 32 is divisible by 2, and we get 16. 16 is divisible by 2, which is 8. 8 is divisible by 2, that's 4. 4 is divisible by 2, we get 2, and 2 is divisible by 2. There's our 1, there's our candle. So the index, again, the number up in the small little number in the radical, there's not 1. That means that it is a 2. So that means I need to make groups of size 2. So there's a group of 2 2s. I already have the I out in the front. Now I also have a 2. There's another group of 2 2s, so I can bring another 2 out. And then anything that's left without a group has to stay inside the radical. So that last 2 stays inside the radical. We're going to multiply the 2's in front. So 2 times 2 is 4. And then 4I radical 2. Then we have one last one. This one has a negative radical that we need to simplify, but it also has a -2 in front. So the -2 in front, the coefficient in front, it doesn't matter that there's a coefficient there. It doesn't matter that it is a negative. We don't care about that negative at all. That's just going to stay there. So the -2 just stays there, and anything that we pull out, we will put out with it. This negative inside a radical, we replace with an I. That's the notation. So now out in front, we have -2 i's so far, and then 45 in the radical. So we're going to use the birthday cake to write the prime factorization of 45. 45 is divisible by 3. That's 15. 15 is divisible by 3. That's 5. And 5 is divisible by 5. And we get 1. There's our candle. So one more time, our index is a 2 again. So we need pairs of 2. There we have 2 3s. So I already had a -2 and an I in the front. Now I also have a 3 in the front. I have this 5 left over that wasn't part of a group, so that has to stay inside the radical. So we keep a 5 in the radical. And then as our last step, we're going to multiply. So -2 times 3 is -6i radical 5.